Hi students, welcome back to my mathematics teaching channel. Last previous lesson, I lost a part of the end of the video. So sorry about that. I would like to continue the ending of the lesson in this video for you. So let's look at the bar up here. The last function I was talking about, y equal 5 minus 2 to the power of x minus 1. Now this function is a transformation of exponential function. And that's why you look at the shape is not like the normal of the shape of the exponential function. So I will show you how you can sketch it very easily, this function, right? So you know that this normal exponential function go this way, right? So this is the shape of normal exponential function. But because we have a negative here in front of the base, what it means is, if you remember the math 12 of the transformation of the function, you know that if you have a negative like this in front of the function, right? This is the exponential function. Then this is the reflection over the x-axis. So therefore, instead of the shape go this normally, the way it is, then you reflect over the x-axis, so it becomes this shape. So now you know this is supposed to go this way because the reflection over the x-axis. Now the number 5 indicates this one. It indicates that normal exponential function, you have a horizontal asymptote at 0, like this one here, right? This one, y equal to the power of x. So this is the horizontal asymptote for the normal function. But when you add 5 to it, it means this horizontal will go up to 5 units, shift up 5 units. So 1, 2, 3, 4, 5. And therefore you have a horizontal asymptote. I draw the dotted line here as the y equal 5, right? So now all what you have to do is, you know the shape gonna be this way, right? Because the reflection over the x-axis, you just need to have at least 2 points, one from here and one down here. So you can connect it and draw this and sketch the function. So I'm going to say, I'm going to plug in x equals 0 into this function to calculate the value of y if x equals 0. So if I plug in x equals 0, I have y equal 5, follow the expression, minus 2 to the power 0 for x minus 1. So the result is 5 minus 1/2, because when you have a negative power, you can twist the fraction, right? You can bring it down like that. And this is negative 1/2. So it's become 4/5. So we know our point is 0 for x, and y is 4/5. So we mark the point right here. This is 4/5 for y and 0 for x. So now we know that this is the asymptote, the shape of our function have to close to asymptote, go through this point. Now we're going to look for the point down here so that we know where it go, right? So let's say I just pick x equal 5, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. So let's say if I pick x equal 5, I calculate again for y. So 5 minus 2 to 5 minus 1. So become 5 minus 2 to the power 4, which is 5 minus 16, and equal minus 11. So I know at this point right here, x equal 5 and y equal minus 11 about here, right? This is the point. So I know that my function will go to this point. So that's how I sketch the exponent transformation of exponential function. And this is the part I missed on the video because I forget to move the computers in the way that you can see it. So now this video will make up for it. So now you will look at the shape and you will say, okay, so what is the limit of this function? If x approaches to negative infinity, that's the question, right? When x approaches to negative infinity, what is the value of y? And by looking at the graph, we know that if x approaches to negative infinity here, when we look at the y graph, right, this is the graph of y value, the y here get closer and closer to 5. So the limit of it equals 5. And by looking at the shape here, you know the limit of this will be equal 5 when x approaches to negative infinity. Now, at another point, let's say if x approaches to positive infinity or something else, then our answer might be different. But if this is the question, when x approaches to negative infinity, so then our answer is 5. And you can see this y approaches to 5 when x approaches to negative infinity. Okay? So that's how you sketch the graph and figure out the limit of the graph. Now, let's move down to this way. Let's say if I make a question, right? I ask you to evaluate the limit of the function 4 to power x. Then what is your answer? So let's look at down here. So the question is, what is the limit of 4 to power x when x approaches to positive infinity? Now, you know that the base is whether 2 or 4. The shape of exponential graph is gonna be the same like this graph. The same like this graph, right? It's just the bigger base, then it's closer and closer to the y-intercept. But this is the shape of the exponential graph. So when x approaches to positive infinity, the function of y keep going and approach to positive infinity. And this means the limit does not exist because it keep going up so high that you don't know what's the value of it. It could be trillion, million, you don't know. So it's a positive infinity, which is the non-exist. So that's how you answer question A here. Now for question B, if I ask you what is the limit of very small number less than 1, 0.9, let's say 0.9 to the power of x. What happened when x approaches to positive infinity? And to evaluate any limit, you can just put in the number, just try to make a number, right? Let's say you key in the calculator, you put 0.9 and you put the power here very high, let's say 100 or 1,000. Then you will see that in your calculator, when you enter, it equals 0 or 0 point something, 0.0018 or whatever, right? So then your answer will be just limit of this function is 0 when x approaches to positive infinity. So remember, if this base is bigger than 1, and you have a huge number of the power, of course, it is getting into positive infinity. But because this number is less than 1, very small number, so when you power a small number, it turns out it becomes very small. So it close to 0. Okay. Now the next question C, it asks for the limit, and I hope you can see it. Yeah. So the question C asks for the limit of phi to the power of 1 over x. When x approach to 0, okay, when x approach to 0. So the question asks you like that. 0 plus, actually. So you know 0 plus is 0 0.001. So on what you do is you can put in the numerical value, 1 equals 1, divided by 0 0.001, because this is slightly bigger than 0, a little bit to the right, right? So when you have 1 divided by 0.001, it turns out to be 1,000. So this is like phi to power 1,000, which is positive infinity. So that's easy answer for the question C down here. And what you have to do is, using your calculator, plug in the number value, and you can see how the limit look like. Some question, if it's easy, you can just have a sketch like this to get the answer. Some question, you need to substitute the number in and find out the answer. Okay? For now, let's say if this question, let me steal a little bit more over here. And let's say if the same question to ask, so question C, okay? Let's say if asked for a limit of the exponential function phi 1 over x. But this time will be x approach to infinity. Okay, so in this case, you know that you can substitute this equal phi when you evaluate 1 over infinity. And 1 over infinity is any small number on the top, whether 1 or 2 or 3 or 4 or 5, divided by a very big number at the bottom, will close to 0. So this will be equal phi to power 0, and that will be equal 1. So the limit of the same function, but if x approach to positive infinity, the answer is 1. If the same question, but asks you the limit of x, of this y when x approach to 0, then the answer is positive infinity. And you can use a numerical value, put in the calculator and figure it out. In the future, when you learn with me about the next lesson, will be not the next lesson, I will talk about the limit of trigonometric function. I would like to teach you math in a sequence of steps followed by my courses, so that you have a better idea, because math is the connection of the sequence order of steps. If you jump in the middle or on the top or somewhere else, it's hard to understand. And that's why I developed my course online, which is allow you to follow my video on YouTube and enroll into my course online. For the sequence of steps, you can have the home picture. You learn from lesson 1, lesson 2, lesson 3, and there's the connection, and it will make you understand better. As long as you finish the prerequisites of Math 12 or Algebra 2, you can continue with the calculus course. Even though if you have the course in your school, but by learning online with my course, you have more, your knowledge is larger because you learn from your school. It might be designed in another part, and my course will design in some other parts different from your school. Of course, the curriculum is the same. I mean, like the content very much the same. However, the way we approach it and the way we explain it slightly different, and the connection slightly different. So you have a broad knowledge and you understand the course in your school better. This course definitely will be in your first year of university for sure, regardless what major you're taking. You might be a nurse or a psychologist, whatever. They want you to have at least one introduction to calculus, because calculus reflect our life in all areas. And that's why I found this course is so useful for all the student. I myself went through the university when I stepped in with a culture shock, because what I learned from high school is totally different from university. And I didn't prepare for that. So it's very hard for the student to taking calculus, the new concept, and then struggling with 4 or 5 courses at the same time. Now, time management is very extremely important to decide your success in university. And so therefore, I'd like to offer you this course online so you can learn for it on your own space, prepare for it, and you be familiar with the calculus before you taking higher and higher level. Okay, so let me basically let me summary how you find the limit. In this lesson, I show you how to find the limit of exponential function, and I haven't shown you the logarithmic function yet, but this is exponential function. You will find using the graph, and you will get used to with some kind of the question, find the limit of this value and that value. So if you want to, at this level, you just try to play around with it. You can use a calculator and evaluate, plug in the number very close to this number and find out. So if they say x approach to positive infinity, you can try 4 to the power 1,000 or 4 to the power 100, something like that. And if it turns out to be a very big number, you know that this is positive infinity. It doesn't have to be that big number value, but it like represent, let's say 4 to the power 1,000 is give you 1,000,000 or whatever. So you know that this will be positive infinity. And what if the number is small base? What happens when the power here is very big, right? So give you a number sense actually. After this lesson of limit of this trigonometric function, we get into the connection between the limit and the derivatives, and you will use the derivative to evaluate the limit. And at that time is a lot of easier than this. Instead of using a tedious task, plug the value in and blah, blah, blah. But at least you have a number sense when you're doing this, and have some idea about the sketching of the function. What is an exponential function? What is the transformation of it? It could be reflection over the x-axis or reflection over the y-axis, shift up or down, something like that, right? So this lesson is useful for you to review Math 12, and also for you to have some idea about this before we get into the derivative and their application. So I hope you enjoy my teaching online on YouTube, and in the future, I can give you when I'm done with the course online, I will give you the domain or the website so you can get into there and register my course. If you register my course online, you learn it in the sequence. It helps you to understand better just watching on the YouTube, right? And you can also do exercise, work on exercise. You can ask me any question online. I can try to my best to take my time to answer you. When I'm done with the course developed online, we will do that together. So bye for now. I hope you enjoy, and if you like my video, please give me a thumb and hit subscribe to my channel. And thank you for your support. Bye for now. Thanks for watching.